Hey there, you rates, Mr. Herman here, and this is the essential assessment skill Evaluate Algebraic Expressions. Learning goals for this one is to look into how we can now create algebraic expressions and the use of the tool substitution. And the success criteria for this one is to create algebraic expressions and evaluate them by substituting a given value for each variable or letter. So this concept of substitution, we have seen this within class. This essential assessment skill will make sure that that skill that you learned within class is consolidated. By substitution, we just mean replace, temporarily replace. Namely, if we see a letter that's within an expression, the question will give us what that letter is equal to, and all we have to do is simply replace that to evaluate or to obtain an answer. So in this case here, evaluate the expression when a is equal to 4 for 17 plus a. This is just saying, well, what's 17 plus 4? Anywhere I see an a, I'm going to replace it with what the question is asking for, in this case 4. 17 plus 4 is equal to 21. So my solution has to be this. Nice and simple. Now, it's not always a that they will give you. Sometimes they'll give you different letters, so just be aware of that. So the third question here, we see x and y. But before we get to this one, this here, evaluate the expression when a is equal to 3. This is asking for what 6 times 3 is. Don't get into the notion of thinking that because the a and the 6 are next to each other, this just means that the answer is 63. This is a big misconception that I've seen for many times in my years of teaching. Whenever there is a number in front of a letter, there's an invisible multiplication sign. And this is just because sometimes that multiplication sign can get mixed up with the letter x, so we just put them together. This just means 6 times a. And since we know a is equal to 3, this is just 6 times 3, which is 18. So our correct response is 18. You will get trickier questions that look like this, where you are substituting now 2, and sometimes you can substitute 3 values within an expression. We need to evaluate this expression when x is equal to 4 and y is equal to 3 of 3x minus y. So it's just a simple replacement. X is equal to 4, and y is equal to 3. So x is equal to 4. This will be 3 times 4. This is the first thing we need to work out, so I'm just going to put these little brackets just to indicate that this needs to be worked out first, minus whatever y is equal to, which is 3. 3 times 4 is 12, so 12 minus 3 is equal to 9. So the correct response is 9. Now, we're going to be looking at substitution, but with real life context as well, and this specific example looks into the formula of obtaining your distance traveled when you know what the speed is and you know what the time is. If you can give me what the speed that you're traveling, how fast you're going, and you can give me how long it took you to get there, the time, I can tell you how far you traveled using this formula here. Or in other words, d is equal to s times t. So this within a specific question, how far will a bus travel if driven at a speed of 65 kilometers per hour? So we've got our speed, and this is traveling for 2 hours. Use the formula to help determine your answer. So we want to know how far this bus traveled. So the distance, this is equal to what our speed is, which is 65, and what our time is, which is 2 hours. Now be careful. Sometimes your time frame might be given in a specific way, and we've got to remember that there are 60 minutes within 1 hour. Okay, so you might get some questions that pop up that says for 1 hour and 30 minutes, this is 1.5 hours. Okay, so be very, very careful about your conversion. This is a nice simple whole number, so 65 times 2 is 130. So that makes sense. If I'm going with 65 kilometers per hour, for every hour I've traveled 65 kilometers, after 2 hours I've traveled 130. That makes sense. So this answer here is 130. A few more questions here. You will get questions that pop up that look like this. Here we're going to complete the number pattern by using a certain expression. The expression is this here, t plus 15. So remember, t just means term. If you give me a term, I can give you an expression to change this. So what you're inputting into the expression give me what's called an output. So a certain output from in the starting term. What we're doing to this term is just adding 15 to it. So for the first one, 3 plus 15, well, this is just 18. The second one is 10, so 10 plus 15, that's just 25. All we're doing is whatever number we've been given, we're adding 15 to it. This is 30, this is 35, and this here is 65. Give me a number, I'll add 15 to it, and I can give you its output. That's all there is to it. Now, the next question, also, there are some questions that have, if you're given a term that looks like this, x, and maybe it's 3, 4, 5, it might say the output is x to the power of 2, or x squared. X to the power of 2 just means x times itself. So if x is the input, the output for this would be 3 times 3, which is 9. If 4 is the input, output would be 4 times 4, which is 16. This one is 25. Okay, so if you see this little expression pop up, x squared, or it could even mean x to the power 3, that's just x times x times x. You're just multiplying the number by itself, however many times the power is indicating. So just be careful of that type of question. Last question. In this case here, we've got what the term is. They've just used w. They haven't. They've given you what your output should be by telling you what here is this rule that they're using. This is the saying, give me whatever w and I'll multiply it by 3. And just to double check to see if it works, from 6 to 18, if you times 6 by 3, you will get 18. So this works. 10 times 3 is 30, so this works. And 50 times 150, 50 times 3 rather, will give me 150, so this works. But what it's not doing is, in the previous one, we've been given what term to put in to get its output. Here, we know what the output is for 90 and 300. We've got to figure out what do we need to put in order to get that 90 and that 300 respectively, if we have to multiply by 3. So there's a little bit of backwards working that we have to use. Now you can't just use logic and think, oh, that's pretty simple. I know 30 times 3 will give me 90. But here, this is this 3w, which is just 3 times w. We have to find out what the opposite of timesing a number by 3 is. Well, timesing, the opposite of timesing is dividing. So to work backwards, get your output and just apply its opposite, or what's called inverse operation. 90 divided by 3 is 30. So 30 times 3 will give me 90. So this has to work. 300, some number times 3 will give me 300. Well, just work out the inverse. This is divided by 3. This has to be 100. So 100 times 3 gives me 300. So these two terms have to work for this particular rule. That's it. That's all there is to it. Make sure that you watch this video from start to finish. If you do need help, I'm going to ask you for your secret number. In this case, the secret number is getting all your date of birth and getting all numbers and multiplying one for the other. Okay. If there is a 0 within your date of birth, don't include that 0. So in my case, I've got 18th of the 4th, 1989. There is a 0 there, so I'm just going to ignore it. So what I'm going to do in the calculator is do 1 times 8 times 4 times 1 times 9 times 8 times 9. My secret number is 20,736. I'm going to ask for your secret number just to ensure I know that you've watched this from start to finish. I can check your date of birth on Compass just to make sure. This is just to call out people if they haven't watched this video. That's it for me, guys. Go ahead and attempt a skill. I'll see you in the next video. Bye bye.